The 5.2-liter engine has proven to be a popular addition to the Jeep Grand Cherokee lineup. But an engine is not much use without a transmission to handle its power. So the 46RH automatic transmission was coupled to the 5.2-liter. This same engine and transmission combination has proven itself in Dodge truck applications. Welcome to Mastertech release number 14. The addition of the 46RH is not the only change to the transmissions used on Grand Cherokee. The 42RE replaces the AW4 automatic transmission that was used when the Grand Cherokee was first introduced. This transmission is used behind 4-liter engines. The 42RE and 46RH are similar in design, providing 3 forward speeds through a transmission section and a 4th gear through an overdrive unit. As you might guess from the difference in names, the 42RE makes greater use of electronic controls. In this program, we're first going to look at the components that make up these transmissions and discuss their operation. Then we'll examine diagnostics, first for the transmission electronics and then general diagnosis. Finally, we'll cover some adjustments and in-car service for the 46RH and 42RE. To describe the components in the 42RE and 46RH, let's start at the front of the 42RE transmission and work our way back. As mentioned earlier, the two transmissions are similar in design, so many of the components are similar as well. At the front of each transmission is a torque converter containing an electronically controlled converter clutch. Clutch engagement is not modulated, as it is in some converters. And when overdrive is selected, engagement normally occurs in 4th gear. As in other transmissions, besides relaying power to the input shaft, the torque converter drives the transmission oil pump. Behind the pump are clutches, bands, and a compound planetary gear set. These provide 3 forward gears and reverse. The front annulus gear and planetary gears are linked to the rear planetary and annulus gears by a common sun gear. The rear clutch links the input shaft to the front annulus gear for all forward speeds. An overrunning clutch prevents rotation of the low reverse drum in one direction. This holds the rear planet carrier stationary in 1st gear drive range. The front band prevents rotation of the front clutch retainer, which holds the sun gear stationary for 2nd gear. The front clutch links the input shaft and sun gear. When engaged, along with the rear clutch, it provides 3rd gear. The rear band prevents rotation of the low reverse drum in either direction, which holds the rear planetary carrier stationary. When the rear band is engaged with the front clutch, it provides reverse. The rear band is also engaged with the rear clutch for manual low to provide engine braking. The intermediate shaft receives the output of the planetary gear set by means of 2 sections splined to the front carrier and rear annulus of the gear set. Below the compound planetary gear set is the valve body. The valve body controls hydraulic flow for the clutches and bands we've just looked at, as well as for the torque converter clutch and the clutches in the overdrive unit. For 4th gear, the overdrive unit uses a planetary gear set to take the input from the intermediate shaft, increase the speed, and relay power to the output shaft. During 4th gear, the overdrive clutch holds the sun gear stationary. The planetary gear serves as the input and the annulus gear as the output. In 1st, 2nd, 3rd, and reverse, the direct clutch links the sun gear to the annulus gear, and the planetary gear set turns as a unit. During the 3-4 upshift, when the direct clutch is being released and the overdrive clutch is engaging, the overrunning clutch takes over for the direct clutch. The direct clutch overrides the overrunning clutch for reverse and during engine braking. At the rear of the transmission, there is a significant difference between the 42RE and the 46RH. The 46RH has a governor which uses centrifugal weights. On the 42RE, governor pressure is controlled electronically by means of a solenoid and transmission control module. We'll look at electronic governor operation in greater detail in the next segment. Before we do, however, let's check your knowledge with a review question. Which of the following transmission elements is applied in third gear? A, rear clutch, B, rear band, or C, front band? The answer is A, the rear clutch. It and the front clutch provide third gear. On both the 42RE and 46RH, hydraulic control of shifting and converter clutch engagement takes place at the valve body. Shift timing for upshifts and downshifts between first, second, and third gears is controlled by shift valves in the valve body. As they are positioned by throttle pressure and governor pressure, these valves apply or release the clutches and bands described earlier. On both the 42RE and 46RH, throttle pressure is regulated by the throttle valve. Its position corresponds to throttle opening. On the 46RH, governor pressure is regulated by the effect of output shaft speed on centrifugal weights. On the 42RE, governor pressure is regulated by a transmission control module, or TCM, using a governor pressure solenoid valve and a governor pressure feedback transducer. The TCM is located on the driver's side of the bulkhead next to the steering column. The TCM bases governor pressure on a number of inputs, including the ignition feed, engine speed, throttle position sensor, vehicle speed sensor, transmission output speed sensor, governor pressure sensor, transmission fluid temperature sensor, and overdrive off switch. Based on these inputs, the TCM positions the governor pressure solenoid valve to admit more or less line pressure into the governor pressure passages. The governor pressure solenoid is located on the valve body. The governor assembly also contains a sensor to provide the TCM with feedback voltage. The 42RE valve body also contains a unique transfer plate for routing line pressure to the solenoid valve and governor pressure from it. Also unique to the 42RE valve body is the transmission fluid temperature sensor we mentioned as an input. It's mounted on the overdrive and converter clutch solenoid assembly. The TCM continuously monitors the transmission circuits for proper operation. When it senses a problem, the control module sets a diagnostic trouble code. The diagnostic trouble code can cause the TCM to enter the default mode. The default mode limits transmission operation to third gear, although manual shifts to reverse and second gear are possible. On both the 42RE and 46RH, 3/4 and 4/3 shifts are controlled electronically through an overdrive solenoid in the valve body. Besides the overdrive solenoid, valve body components used for 3/4 shifts include a 3/4 shift valve, timing valve, and quick fill valve. A boost valve provides increased lubrication flow and higher apply pressure not only for the overdrive clutch but for the converter clutch as well. In 42RE transmissions, the overdrive solenoid is controlled by the transmission control module. In 46RH transmissions, the overdrive solenoid is controlled by the powertrain control module, or PCM. The PCM, or TCM, bases its operation of the overdrive solenoid on a number of inputs. These include the overdrive off switch, throttle position sensor, and vehicle speed sensor. The 46RH uses the engine coolant temperature sensor as an input, whereas the 42RE uses the transmission fluid temperature sensor mentioned earlier. Additional 42RE inputs include the output shaft speed sensor and engine speed. Based on these inputs, the PCM, or TCM, will operate the overdrive solenoid to upshift to or downshift from fourth gear. For example, Consider the effect of the transmission fluid temperature in the 42RE. The TCM will not allow fourth gear when fluid is below approximately 30 degrees Fahrenheit, or converter clutch engagement when fluid is below about 50 degrees Fahrenheit. If transmission temperature exceeds 260 degrees Fahrenheit with the transmission in fourth gear, the TCM will downshift to third gear and light the LED in the overdrive off switch until fluid temperature drops to 230 degrees Fahrenheit. It may also operate the converter clutch during this time. The converter clutch works in much the same way as overdrive. The TCM, or PCM, operates a converter clutch solenoid based on a number of inputs. Besides the converter clutch solenoid, other valve body components associated with clutch operation include the converter valve, converter timing valve, and switch valve. As mentioned earlier, the boost valve provides higher apply pressure for converter clutch operation. Inputs affecting converter clutch operation include the overdrive switch, throttle position sensor, engine speed, and vehicle speed sensor. The 42RE adds the output shaft speed sensor and transmission fluid temperature sensor, while the 46RH adds the engine coolant temperature sensor, map sensor, and brake switch. Normally, converter clutch engagement takes place in fourth gear, but the clutch can be operated in third gear if overdrive off has been selected, or as we've seen in the case of an overheat condition. That basically is how the 42RE and 46RH operate. You may want to study the hydraulic flow diagrams in the service manual to get a more detailed look at valve body operation. Next, we're going to relate some of the things we've learned so far to transmission diagnosis. But before we do, let's try another review question. On the 42RE transmission, shift solenoids are used to control the shifts between first, second, and third gears. True or false? The answer is false. The 42RE uses shift valves but not shift solenoids to control the shifts between first, second, and third gears. The 42RE does, however, have a governor pressure solenoid that allows the TCM to regulate governor pressure electronically. The approach you take when diagnosing the 42RE or 46RH will depend on your preliminary assessment of the problem. In this section, we're going to concentrate on isolating trouble that has an electrical or electronic cause. What sort of symptoms might indicate electrical or electronic problems? On the 42RE, these might include, first of all, a default to third gear, but they may also include delayed engagement, delayed shifts, or no kick down. And, of course, problems with 3/4 upshifts and 4/3 downshifts and converter clutch engagement can also indicate electrical problems. On the 46RH, fewer transmission symptoms are related to electrical problems. They include problems with 3/4 and 4/3 shifts and converter clutch engagement. At this point, a quick visual inspection of electrical connections and retrieving trouble codes with a scan tool can reveal any obvious problems and save you some time. On vehicles equipped with the 42RE, connections on the transmission include the 8-way bulkhead connector. Check it for damage, terminal spread, or push-outs. Also on the transmission, check the output shaft speed sensor and vehicle speed sensor. On the engine, check the connection at the throttle position sensor. Inside the vehicle, be sure to check the connection at the transmission control module and the overdrive off switch. Checks on the 46RH are similar. The location of electrical connections and components on the 42RE are illustrated in the Powertrain Diagnostic Procedures Manual for that transmission. The 46RH does not use as many electronic components. Their diagnostics are part of those for electronic fuel injection and are contained in the 5.2-liter engine Powertrain Diagnostic Procedures Manual. Besides illustrations of electrical components and their locations, The manual for the 42RE contains other useful features to aid in diagnosis. A road map at the front of the book illustrates what the scan tool can do. At the beginning of the manual, there is a description of transmission electronic controls. The manual then describes each diagnostic trouble code and lists its possible causes. By the way, two types of diagnostic trouble codes can be retrieved with the scan tool. Codes are active if a fault is still present. Once active codes are corrected, they are cleared. However, all active codes are logged as stored codes as well. Stored codes indicate a fault that is not currently present. They may be intermittent and are usually an indication of wiring or connector problems. Stored codes can be cleared with the scan tool. These trouble codes can also be retrieved by cycling the ignition switch on 3 times and counting the flashes of the LED in the overdrive off switch. Following the trouble code description in the 42RE Diagnostic Procedures Manual are illustrations of component location and then step-by-step diagnostic procedures. The rear of the manual also contains some valuable information, including a schematic of the transmission control module, inputs and outputs. We've told you that you can retrieve diagnostic trouble codes with the scan tool, but we didn't tell you where to hook it up. For the 46RH, connect the scan tool to the data link connector near the powertrain control module in the engine compartment. For the 42RE, connect the scan tool to the SCI data link connector to the left of the center console. The scan tool can do more than retrieve diagnostic trouble codes. Remember the road map at the beginning of the 42RE manual? It will give you an indication of the areas covered. From state displays, you can obtain sensor readings as well as the status of transmission inputs and outputs. Using the actuator test section, you can actuate governor pressure, torque converter clutch, or 3/4 shift solenoids. You can also illuminate the LED in the overdrive off switch. You can perform some of the same actuator tests on the 46RH, as well as take voltage readings of some transmission-related sensors. Of course, you can also retrieve diagnostic trouble codes related to the 46RH. The Powertrain Diagnostic Procedures manuals and the scan tool will help you isolate problems related to the electrical and electronic side of the transmissions. But what about problems that aren't electrical in origin? We'll deal with diagnosis of these problems right after a review question. And by the way, a 42RE diagnostic manual will help you answer the question. Which of the following is not a diagnostic trouble code used with the 42RE? A. Vehicle speed input. B. Governor pressure solenoid. Or C. Map sensor voltage too high. The answer is C. Map sensor voltage too high. The map sensor is used as an input for 46RH operation, but not for the 42RE. If an electrical problem is not suspected as the source of a transmission problem, you'll need to use a different diagnostic approach. This approach is contained in the service manual diagnostic sections for the 42RE and 46RH. It provides a logical, step-by-step method of isolating a transmission problem. Which procedure you use will depend on whether the vehicle is drivable and what the symptoms are. Let's look at some of the checks and tests you'll need to make for a vehicle that can still be driven, beginning with fluid level and condition. Low fluid level can cause a variety of symptoms, including delayed engagement, delayed shifts, and slipping in gear. It can also lead to burnt fluid. Of course, if the fluid is low enough, the vehicle will not move at all. Before checking the fluid level, make sure the vehicle is on a level surface and the fluid is at normal operating temperature, about 180 degrees Fahrenheit. If the dipstick is too hot to hold between your fingers, it's probably hot enough. With the engine at idle and the parking brake applied, shift the transmission through all the gear ranges and back to neutral. The fluid level is acceptable if it is in the cross-hatched area marked OK on the dipstick. The fluid should be dark to light red in color and free of contamination. Remember, the shift lever must be in neutral and the fluid at normal operating temperature for an accurate check. Fluid that is black or brown or that contains a lot of debris indicates the need for an overhaul. If the fluid is discolored but not severely burnt, you may be able to simply flush the cooler lines and change the fluid and filter. Whether you change fluid or add fluid, be sure to use Mopar ATF Plus, since it is the preferred fluid for the 42RE and 46RH. Dexron 2 may only be used to top off the transmission. If the transmission is losing fluid, you'll need to find the cause. The service manual contains a diagnostic procedure that can help you to isolate leak locations. If you have access to previous Mastertech programs, it would also be helpful to look at the April 1992 release, which covered fluid leak diagnosis. Earlier in the program, we mentioned that throttle pressure and governor pressure positioned shift valves in the valve body, producing shifts between first, second, and third gears. That's why our next check, throttle cable adjustment, is so important. A misadjusted throttle cable can cause a variety of symptoms, including delayed shifts, slippage in forward drive gears, lack of kickdown or downshift, lack of upshift, and sluggish acceleration. A properly adjusted throttle valve cable will cause the throttle lever on the transmission and throttle lever on the throttle body to move simultaneously. To check the adjustment, first make sure the ignition is off. Then make sure that the engine throttle lever is in the curb idle position and that the transmission throttle lever is fully forward. Then slide the cable end off the attachment stud on the throttle body lever. At this point, the cable end should be within 39 thousandths of an inch of aligning with the attachment stud. This corresponds to 1 tick on the adjustment cable. In addition, once the cable is reattached, the transmission throttle lever and the throttle body lever should move simultaneously as the throttle is moved from idle to half throttle. If misalignment exceeds 39 thousandths of an inch, or if the levers do not move simultaneously, the cable needs to be adjusted. To do this, first make sure the throttle body lever is at curb idle, the throttle cable is disconnected, and the transmission throttle lever is in the forward position. Then press and hold the cable lock button inward to release the cable. Center the cable end to within 39 thousandths of an inch of the attachment stud and release the lock button. After the adjustment, make sure transmission and throttle body levers move simultaneously as the throttle body lever is moved to half throttle. Misadjusted or damaged gear shift linkage can cause some of the same symptoms as a misadjusted throttle valve cable. Symptoms include delayed engagement or delayed shifts, lack of reverse, lack of drive range, or both, slippage in drive or reverse, lack of kickdown, creeping in neutral, sluggish acceleration, and no start in park or neutral. The surest sign of misadjusted gear shift linkage is a vehicle that will not start in park or neutral. The Grand Cherokee service manual contains procedures for adjusting the shift cable and park interlock cable. They're in the in-vehicle service subgroup of the transmission section. At this point, you should road test the vehicle. Road testing can serve several functions. If the checks made so far have remedied the trouble, it can verify proper operation. Or road testing can confirm the customer complaint and form the basis for any additional troubleshooting. So be sure to road test thoroughly and note all symptoms and which gear or range they occur in. Could the torque converter be causing the problem? Is acceleration sluggish? Or do you need an abnormal throttle opening to maintain speed? Is the transmission skipping any gears? What about shift timing? Are shifts early or delayed? Is engagement harsh? What is the shift quality? Are shifts harsh or spongy? Is there engine flare to indicate slippage in any gear? Once you've performed the road tests and noted all the symptoms related to transmission operation, you'll need to analyze the results and decide what the next step will be. If there was sluggish acceleration or an abnormal throttle opening was needed, a stall test will help you determine if the torque converter is doing its job. For this test, you'll need to have some way of obtaining engine RPM readings, and the transmission fluid must be at the normal level and at normal operating temperature. To conduct the test, block the front wheels and apply the parking and service brakes. Start the engine and make sure no one is in line with the front or rear of the vehicle. At this point, shift the transmission into the drive range. And while noting engine RPM, open the throttle completely for no more than 5 seconds. The time limit of 5 seconds helps to keep the transmission from overheating. In fact, after the test, you should idle the engine for 20 seconds in neutral to cool the transmission fluid. Also, the acceptable range is 1800 to 2300 RPM. Discontinue the test immediately if the engine races. If the stall speed is not within specifications, consult the stall test analysis in the service manual for possible causes. The stall test can help determine the cause of some symptoms detected during the road test. But what about others? For example, shift quality or timing or slippage within a particular gear. For these, you'll want to relate specific symptoms to specific elements in the transmission. Fortunately, there is a chart in the service manual specifying which clutches and bands are operating in a particular range and gear. An accompanying description explains how to relate symptoms to transmission elements. For example, suppose slippage occurs in all forward drive gears and ranges, but not in reverse. Using the chart, we see that the rear clutch is the element used for all forward gears and ranges, and that is the element we should concentrate on. Following the analysis of the road test, pressure tests will help determine whether the hydraulic circuit for a particular element is the cause of a symptom. To conduct the tests, you'll need a way of setting or reading engine RPM, and a 100 psi gauge and a 300 psi gauge. The location of the pressure test ports on the 42RE and 46RH is similar. From front to back on the right side of the transmission are the front servo, accumulator, governor, and rear servo test ports. By the way, because of the higher pressure readings, the 300 psi gauge must be used at the rear servo test port. The overdrive test port is at the left rear of the transmission case. Always use the 300 psi gauge at this port as well. The service manual contains a series of 6 tests for checking the operation of hydraulic circuits. You may need to select one or more of these tests to isolate the cause of a particular symptom. To get a better idea of hydraulic testing these transmissions, let's look at test 1 on the 42RE. Using the scan tool will allow you to set engine RPM to the specified figure. For this, as for all pressure tests, the vehicle must be raised so that the wheels can turn freely. For test 1, connect the 100 psi gauge to the accumulator port. This gauge will read line pressure supplied to the rear clutch. Connect the 300 psi gauge to the rear servo port. This gauge will measure apply pressure of the rear band used for reverse and manual low. Next, disconnect the throttle and gear shift cables at the transmission to allow the manual shaft and throttle valve lever to be operated at the transmission. Start the engine and set it to 1000 RPM. Then move the gear shift lever at the transmission all the way forward into low range. And while noting the gauge pressures, move the throttle lever from the full forward to the full rearward position. Line pressure at the accumulator port should rise from 54 to 60 psi to 90 to 96 psi as the throttle lever is moved. The rear servo pressure should be the same as line pressure, within 3 psi. So, what does this test tell you? For one thing, the line pressure gauge gives you an indication of how the pump and pressure regulating valve are doing, and whether the rear clutch is leaking. The rear servo gauge gives you an indication of whether pressure is available for the low reverse band, which operates in manual low and reverse. Other tests can be used to confirm or further isolate the cause. So, low pressures in test 1, but normal pressure in the 2 range in test 2 indicates a leaking low reverse servo. Low pressures in test 1 and normal pressures in reverse in test 4 indicates a leaking rear clutch. The service manual contains a chart to help you interpret test results. So, suppose the pressure checks out. Does that mean that particular transmission element is working properly? Not necessarily. A piston or servo could be stuck or damaged. In that case, the air pressure checks described in the service manual provide a way of checking out the transmission further. They're also a good way to confirm proper operation after an overhaul. Remember that rear servo we pressure tested? The air pressure test port is located here, under the valve body. The service manual also provides comprehensive diagnostic charts that can steer you in the right direction during troubleshooting. We've talked a lot about what you'll find in the service manual, but TSBs also provide essential diagnostic information. There's a list of TSBs for the 42RE and 46RH in this month's reference book. Our next review question will allow you to do some troubleshooting of a hypothetical sort. You may need to consult the service manual to come up with the answer. During a road test, a 42RE transmission exhibits slippage in reverse and manual low. Which clutch or band should you investigate first? A, rear clutch, B, rear band, or C, direct clutch? The answer is B, the rear band. As the chart in the service manual shows, the rear band is the element operating in reverse and manual low. As a result of your troubleshooting, you may need to perform a number of adjustments on the transmissions. We've already discussed throttle valve cable adjustment and gear shift linkage. 2 other adjustments are to the front and rear transmission bands. These band adjustments, along with fluid and filter change, are also part of the severe usage maintenance schedule, which should be performed every 12,000 miles. The front band adjusting screw is located on the driver's side of the transmission, above the throttle valve lever. You'll need to raise the vehicle for both the front and rear bands. To adjust the front band, first, loosen the band adjusting screw lock nut and back it off 4 to 5 turns. Make sure the adjusting screw is free to turn. Next, using an 8-point 5/16" socket and 3-inch extension, tighten the adjusting screw to 72 inch-pounds. If you use the special adapter with the inch-pound torque wrench, tighten the screw to 47 to 50 inch-pounds. At this point, on the 42RE, back off the adjusting screw 3 5/8 turns. On the 46RH, back off the screw only 2 1/2 turns. Then, while holding the adjusting screw, tighten the lock nut to 30 foot-pounds. The transmission oil pan must be removed for the rear band adjustment. The rear band adjusting screw is located next to the valve body on the rear band lever. To adjust it, loosen the adjusting screw lock nut 5 to 6 turns. Make sure the adjusting screw turns freely. Next, tighten the adjusting screw to 72 inch-pounds. Back it off 4 turns on the 42RE and 2 turns on the 46RH. Then tighten the lock nut. While the pan is off, it's a good idea to inspect the filter and replace it if necessary. Also, be sure to clean the pan magnet before installing the pan, using a new gasket. We've mentioned the maintenance requirement for severe service. In normal service, the fluid and filter should be replaced every 30,000 miles. Besides the filter, there are a number of other components on the valve body which are serviceable. On the 42RE, for example, the governor pressure sensor and solenoid are serviceable. To replace them, first, disconnect the sensor and solenoid. Then remove the retainer plate governor body, and gasket from the transfer plate. The governor pressure sensor is held in place by a small M-clip. The governor pressure solenoid can be pulled straight out of the governor body. On both the 42RE and 46RH, the converter clutch and overdrive solenoid assembly can also be replaced, but the valve body must be removed to do so. On the 42RE, the transmission fluid temperature sensor is located on this assembly. If troubleshooting does lead you to remove the valve body, keep in mind that the park neutral position switch must be removed first. This switch must also be removed when the valve body is installed. Also, when reinstalling the valve body, make sure the park rod engages the park pawl and does not simply locate in a cavity above the pawl. Servicing transmission cooler lines and fittings is another area of concern on these transmissions, so be sure to consult the service manual for the appropriate procedures. Now let's check your knowledge of band adjustment with a final review question. On both the 42RE and 46RH transmissions, the amount of torque used to tighten the adjusting screws for both the front and rear bands is the same. True or false? The answer is true. Both front and rear band adjusting screws on both the 42RE and the 46RH are tightened to 72 inch-pounds when not using the special adapter. The number of turns the screws are backed out, however, is different in each case. That about wraps up this Mastertech release. A basic understanding of transmission operation and a systematic approach to troubleshooting should make the 42RE and 46RH easier to service. Be sure to check your course guide for classes related to the 42RE and 46RH transmissions. And we'll see you next time here on Mastertech.